All right, everybody, here we are. We're going to do an example from section 6.3. This is from slide 28 in a little more detail. So we're talking about confidence intervals. Hopefully you've looked at the first slides for this section. You kind of have a little bit of idea what we're doing, but I'm going to show you the calculations here. So it gives us a sample, and it talks about how we have a p hat, which stands for a percentage, a proportion of people, and it has an n. And then it also tells us that, or asks us, find the margin of error, that's this formula, that corresponds to a 95% confidence level. So there's a formula for error, and it says z and then alpha over 2. It looks a lot scarier than it is. That stands for a z-score. And I have a little cheat sheet down here that I'm going to hopefully have time to talk about at the end. But the z-score that corresponds to that percentage is 1.96. And so that's going to be this part of the formula. And then I'm going to multiply that by p hat times q hat. So p hat is 0.85. Q hat is 0.15. Remember, that's the complement of p. And I'm going to divide that by n. Now, if you want to pause the video and plug that in, make sure your technology is working. You can, but the error that you should get when all is said and done is 0.022. That is the answer to part A. Part B, it says find the 95% confidence interval estimate. This right here is the form of a confidence interval, which I'm abbreviating CI. And it says that we're going to have p hat, which is given to us, 0.85. And then we're going to subtract the error. And on the other side, we're going to add the error. So it's kind of like you're giving and taking a little bit on both sides. P, again, is the population proportion. And all throughout statistics, we're using a sample to make a conclusion or an estimate about the entire population. And so when I simplify the left and simplify the right, the thing I'm going to be left with is the confidence interval. So when I subtract this, I have 0.828. And the other side, when I add it, I have 0.872. Again, in terms of percentages, this is about 82.8%, and this is about 87.2%. So what does this all mean? It means that there's 95% of the time, right? 95% of the time, the true population proportion for people that know what Twitter is between 82.8% and 87.2%. So for part C, when it says, based on the results, can we safely conclude that more than 75% of adults know what Twitter is? Well, the conclusion here is that 95% of the time, the number of people who know what Twitter is between 82.8 and 87.2. So 75% is much less than 82%. And so if 82% is going to be known, then 75% is included in that. So the conclusion is that yes, more than 75% of adults know what Twitter is. I have a few extra moments here, so let me just say a few about where these numbers down here come from. 95% comes from our normal curve. And so when you think about our normal curve, the 95%, if that goes in here, that means you have 2.5% on each end. And this z-score right here, that z value, z, if you use your table or technology, will be 1.96. It's calculated for you, but you could find it